Oh yeah. Wow. Right.
Okay, so this is being recorded. It's a very quick meeting for MSE 280, going over a quick Excel review. This is for calculating tensile strength, modulus, and also how to get the 2% offset. So I'm gonna do it really quick. So she's actually going to give you an Excel chart, and even if they don't, your professor, just type it in like this: load, engage length. When you're doing it in Excel, I recommend doing strain first, because if you calculate stress then strain and you try and graph it, it's gonna flip the axes. It likes having the X first. But for strain, the formula for strain is delta L divided by initial length. So here you're just gonna click equals, and we're gonna click gauge length here. That means that when you pull this down, it's going to enter the next value for each one of them. And you put minus, and the initial value for this is actually 50.5, because you can see there on the actual load chart, when the load is 0, that's the length. So this is our unstressed load. I'm going to put parentheses around this though. And then after that is done, you're going to put divided by 50.50. Remember to keep your sig figs. When you hit enter, the first value is going to be 0, but you click on that box, click the little arrow in the bottom right and drag it down, and it's going to calculate it for all those boxes. So that is your strain. For stress, you're going to come down here, you're going to hit equals, and start a parenthesis. So the formula for stress is 4 times the force divided by pi times the diameter squared. So we're going to put 4 times our force here is 0, so it'd be 4, and that's going to change for each different box. Close parenthesis divided by open parenthesis pi. When you enter pi, you put pi open parenthesis close parenthesis. That's how it takes in pi. I know that sounds weird, but that's how you type it in. Times open parenthesis again, and for this one, I'm just going to do a random initial diameter. I'm going to do 12.5 here to the power of 2, close parenthesis, close parenthesis again, hit enter. There we go. So that's going to be our stress, and then pull that down and hit, and there you go. That's stress and that's strain. Now, what's really cool is that for each of your questions, it's going to give you a slightly different diameter, but you don't have to change it each time. You come back here to this initial one, and say they changed it to, okay, now my radius is 14.6. Hit that, hit enter, then click it and drag it down again, and it'll actually recalculate for that every single value. Now, what modulus is the slope, which is going to be rise over run, or stress divided by strain. And the easiest way for you to find that, you always want to find the modulus, or Young's modulus, in that first initial part before the curve starts stretching out. So what I recommend doing is, if you pick this to be your first point and this to be your second point, then it's just going to be this value divided by this value. And let's do that real quick. Let's go. Okay, so it's going to be modulus. Enter. We can't do it for this line because it doesn't like 0 divided by 0, but we're going to put equals stress divided by strain. Hit enter. There's our value. Drag that down. And there you go. So you want to pick it from really early on, because once you start getting down here, it starts getting wonky. So I recommend choosing this first value here. And this is in megapascals. This is in megapascals, and strain has no units. That's why the modulus is in megapascals, because stress is in megapascals and strain has no units. And when you divide them, you get it in megapascals. When you're asked what the modulus is, it's going to give it to you in megapascals, but the question's probably going to ask you in gigapascals. And to convert from giga to mega, all you have to do is divide by 1,000. All right, last thing. Well, also tensile strength. Tensile strength is just going to be your maximum stress value. So just look at this chart here. 416 would be my max for this one because it's my highest stress value. That would be the tensile strength. Lastly is 2% offset. So I'm just going to highlight my data here, go to insert, go to charts, give me a little, this guy looks cool. There we go, we got him. Now I want to do my 2% offset. So what I'm going to do is I'm going to click on this axis here. I always gets me messed up here. Here we go. So double click it, go over here to axis options, make the maximum 0.005 because it's asking for a 0.2% offset, which we need to know where the 0.002 is. Hit enter there. So we have a nice little graph, and I'm also going to do the same thing to the y-axis because it'll help us get a better bead for where it's at. So we're going to make the maximum for this 250. And there we go. Now we can much easier see where each thing is. I'm also going to change. Hold up. What would happen if I change this? Let's make this 20. Let's see what that does. Oh, beautiful. Perfect. All right. So there's that. Now the next thing we need to do to find 2% offset, we're going to go to insert, shapes, click on the line, find the point where it hits there at 0, and just match that initial curve to the best you possibly can. Pull it out, let go of it, and just drag that to where it hits 0.2. So about right. Oh, at 0. I don't know why it went to -10, but we can see right here it's almost hitting dead on that point, and that point is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I go over here to my stress. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can say that this is hitting at approximately 210 megapascals for the 2% offset, 0.2% offset. All right, any questions regarding this for an Excel review? Anyone at all? All right, if that's all, I'm going to upload this video, and yeah, I'll get it to you guys. You guys have a great day.